Hello to everybody. I'm Deborah Hugon and I have been working in STAM since 2020 as a junior project engineer in the modeling and simulation area. STAM is a SME with a multi-year experience in European project, and a large part of his activity is related to safety and security aspects of critical infrastructure in the transportation engineering. Within Values project, we will develop a risk analysis methodology to be implemented in a web application. The tool will be tested in use case 6 with the purpose of evaluating the risk of an agricultural automatic vehicle. Values project aims to reduce time and cost for the verification and validation of automated systems, as well as increase safety and security performances. We will develop a risk analysis methodology and a tool to protect the different assets of the system, such as people, data, equipment, and so on. Moreover, this tool is necessary to guarantee a continuity of the service and to safeguard the business activities. Finally, the risk evaluation is a fundamental step to prevent, respond and mitigate the effects of a failure of the system, or an accident, or a physical or a cyber attack. We could present our risk analysis methodology in different steps. First of all, several scenarios will be generated according to the inputs, which are the historical data, economic figures, a list of the safety and security measures installed in the site or on a system, a model of the system to be analyzed, and so on. Each scenario is set in a defined time slot and takes into account a failure or an attack. After that, these scenarios will be simulated considering the effect of installed countermeasures. The next steps aim to evaluate the likelihood and the impacts of each scenario in order to provide comprehensive outputs and compare the result of multiple configurations. The final outputs that are provided to the user are mainly 5. The first one is the risk level evaluation, therefore the evaluation of the economic risk for year. The second one is the number of casualties, which implicate serious consequences for companies in terms of money and not. The third one is similar to the previous one, and it is the number of injuries. The fourth one is the estimation of the physical damages following an event. For example, a damage to a machine or against a part of the infrastructure affected. The last one is the evaluation of the revenue losses in case of an event. The risk analysis methodology just presented is implemented in the RAMSES tool, a computation engine dedicated to a quantitative estimation of risk. Here you can see our latest tool built in RAMSES. This is a general-purpose web-based application focused on the risk assessment for industrial infrastructures. As we can see in the home page, it is possible to proceed with the modeling of the baseline, where you can model the current or the basic state of the system. After that, multiple configurations could be inserted where the baseline configuration can be changed based on your preferences, such as new security measures, a different number of people present, new areas, and so on. In this second figure, you can see the tool page where the infrastructure is modeled, therefore where the user can select the security measures and areas to be modeled. Finally, the results dashboard is shown. This reports several indicators which can help the user to understand the risks and the vulnerabilities of the system at a glance. Moreover, it is possible to download a detailed report containing data about the thousands of risk scenarios generated by the tool in each run. Considering the current state of our tool and methodology, Several improvements are expected to be introduced within various projects. First, since the analysis will be carried out for an automated system, particularly an agricultural vehicle rather than an infrastructure, the methodology and the algorithm will be refined to take into account peculiarities of this domain. Furthermore, the methodology will adopt a new algorithm to finally model cascading effects, as it is nowadays a very crucial issue, especially in IoT devices. This feature will have also to cope with the lack of historical data, which could be critical in the case of automated systems, which are very recent. In this regard, approaches based on AI will be implemented to overcome the data availability. Finally, the tool will provide also real-time analysis functionality. This will enable to the user to have a rapid assessment of potential damages in the case of a failure detected by system sensors. Thank you for your attention. Visit the Values website for further information and follow us on LinkedIn, Twitter and YouTube for continuous updates on the project.